Lena was 10 years old when her school assigned a project titled The Most Dangerous Predator in Earth's History. She spent 3 afternoons on it, printed 4 photographs of a Tyrannosaurus rex, and turned it in with complete confidence. Her teacher handed it back the next morning with 4 words in red pen at the top. "Keep looking. You're wrong." 6 weeks later, Lena had filled an entire notebook with creatures her science textbooks never once mentioned. Every single animal on this list was more physically dangerous than any dinosaur ever documented in the fossil record. Not one of them is a dinosaur. We are starting in the ocean, because the ocean is where Earth has always kept its most extreme ideas about what a predator can actually be. The largest great white shark ever confirmed on record was just over 20 feet long, with a bite force of roughly 4,000 pounds per square inch. Megalodon was 60 feet long, nearly the length of a standard bowling lane, and its bite force has been calculated between 25,000 and 40,000 pounds per square inch. A great white bites hard enough to crush a surfboard cleanly in half. Megalodon bit hard enough to collapse the skull of a sperm whale. This is not a guess. Paleontologists have recovered whale bones with megalodon puncture marks driven straight through the material, still preserved millions of years after the fact. Megalodon teeth turn up on the floor of every major ocean on the planet, some measuring over 7 inches from root to tip, roughly the size of an adult human hand laid flat. Its jaw was wide enough to swallow 2 adult humans side by side, and its body proportions were closer to a whale shark than a great white, built entirely for raw crushing power, not speed. The last confirmed megalodon fossils date to 3.6 million years ago. Modern humans are only 300,000 years old, which means we missed sharing the ocean with it by a remarkably narrow margin. The second creature is one most people would predict belongs on this list, a giant snake, and for once, the instinct is correct, just completely underscaled in every direction. Titanoboa was discovered in 2009 by the Smithsonian Tropical Research Institute inside the Cerrejón coal mine in northern Colombia. The research team initially mistook the vertebrae for fragments of fossil turtle shell. They were simply too large to register immediately as belonging to any known snake species. The completed reconstruction measured 46 feet long, nearly 3 times the length of the largest anaconda alive today, and weighed approximately 2,500 pounds. A snake at that weight cannot chase prey at any meaningful speed, so Titanoboa did not hunt by moving fast. It waited submerged in shallow water, detected body heat from surface disturbances using thermoreceptors, then struck and constricted before its target had time to process that anything had moved. Its documented prey included large ancient crocodilians, which it killed by constriction and swallowed whole, bones, skull, and all. Titanoboa existed roughly 60 million years ago, approximately 5 million years after the extinction event that removed the dinosaurs from the top of the food chain, and it filled that vacancy completely. It is not a dinosaur. It is what the planet built after the dinosaurs were finished. Most people have never heard the name of the third creature, which is one of the stranger gaps in how prehistoric life gets taught in schools. Sarkastodon lived in what is now Mongolia between 35 and 40 million years ago, and it was the undisputed apex land predator of its entire continent during the Eocene epoch. Picture the general frame of a large modern bear, then triple the jaw pressure, extend the skull forward to hold teeth designed for bone crushing rather than tearing, and remove every omnivorous dietary tendency entirely. Sarkastodon's documented prey included early rhinoceroses and primitive titanothers, 4-ton herbivores, which gives a clear sense of the size bracket it was operating in. Modern lions run between 300 and 550 pounds. Sarkastodon body mass estimates fall between 800 and 1,200 kilograms, roughly 3 adult lions pressed into a single carnivorous frame. It belonged to the mammalian order Creodonta, which held the apex predator position on land for approximately 40 million years, and Sarkastodon was the largest animal that order ever produced. When it finally vanished from the fossil record, no stronger predator replaced it. Climate shifts across Central Asia gradually eliminated the megafauna it depended on, and Sarkastodon followed that food source into extinction. The fourth creature has a name that means king lizard, which is wrong on every possible level because it is not a lizard, and the scientists who named it in 1834 knew that almost immediately. Basilosaurus was a whale, an early one, and it lived roughly 40 million years ago, reaching up to 60 feet in length with a long serpentine body that looked almost exactly like the sea monsters described in ancient maritime mythology. It still had small, vestigial rear legs inherited from when its land-walking ancestors first entered the water, non-functional, weight-bearing for nothing, just a physical record of the evolutionary transition preserved in bone. The clearest evidence of what Basilosaurus actually hunted comes from a fossil site in Egypt called Wadi al-Hitan, the Valley of the Whales, where its skull material was found alongside the remains of Dorodon. Dorodon was a smaller early whale, roughly dolphin-sized, and the Dorodon skull specimens at that site had Basilosaurus bite marks driven through the cranial bone, concentrated specifically on juvenile animals. Basilosaurus was actively hunting its own evolutionary relatives, selecting the young ones with enough deliberate precision to distinguish them from the adults in the same population. Nothing in the modern ocean hunts with quite that specific combination of scale, biological intelligence, and targeted prey selection simultaneously. The fifth creature requires a brief warning for anyone with a strong reaction to large insects, because what comes next is a real animal, not a film concept. Arthropleura was a myriapod closely related to millipedes, and it lived approximately 300 million years ago during the Carboniferous period. It was 9 feet long. At its widest point, Arthropleura's body measured roughly 18 inches across, wider than most adult human shoulders, moving on more than 30 pairs of legs running continuously from head to tail. The reason it reached that size is atmospheric. During the Carboniferous, oxygen concentration in Earth's air sat at approximately 35%, compared to the 21% present today. Myriapods and insects breathe through passive diffusion across their body surface rather than through dedicated lungs, which means atmospheric oxygen concentration directly sets their maximum possible body size. At 35% oxygen, the physics allowed a millipede-plan body to reach 9 feet. At today's 21%, the same biology caps at roughly 15 inches under ideal conditions. Fossilized Arthropleura trackways found in Scotland show its body width pressed into ancient mud at roughly the diameter of a car tire, the most viscerally legible fossil evidence on this entire list. It is not a dinosaur. Dinosaurs would not exist for another 75 million years after Arthropleura was already long gone. The sixth creature is the most recent, and in certain ways the most unsettling, because it was alive when human beings first arrived in New Zealand, and the record of what happened next exists on both sides of the encounter. Haas eagle had a wingspan approaching 10 feet, talons that matched modern tiger claws in both length and curvature, and a hunting method built around high-speed vertical dives onto large prey from above the forest canopy. Its primary target was the moa, a group of flightless birds, some species standing 12 feet tall and weighing over 500 pounds, which it killed by driving both sets of talons through the back of the skull at estimated dive speeds above 50 miles per hour. Maori oral tradition contains specific, detailed descriptions of a giant predatory bird called te hokioi, described as carrying away children and occasionally attacking adults, recorded centuries before Western science had any knowledge the eagle existed. When paleontologists compared the te hokioi descriptions against the recovered Haas eagle fossil record, the physical details aligned with unusual precision: wingspan estimate, attack angle, habitat association with high forest canopy, and prey size range. The bone chemistry of Haas eagle specimens shows moa as the dominant food source alongside smaller prey, and several researchers have noted that given the eagle's confirmed claw dimensions and strike force, human children fell within its plausible prey size range during early Maori settlement. It went extinct around 1400 AD, within a century of Maori arrival and the hunting pressure that collapsed the moa population, removing the food base the eagle required, ending the species faster than almost any non-volcanic extinction event in New Zealand's geological record. Lena finished her notebook and did not go back to the T-Rex photographs. The creatures that actually ran this planet, on land, in water, from the air, were stranger and more extreme than any single fossil exhibit in any school textbook she had ever been given. If you want the next chapter of that same story, there is already a video on this channel covering the 5 mass extinction events and the causes behind them that your science class almost certainly got wrong, including one that is closer to the present than most people realize.